Hi, welcome to class number 2. Today we are going to look into how can we manage and understand data using R. So we are basically going to continue looking a little bit more into R Studio to complement some of the things that we saw in our first class. And this is mostly going to focus on the different types of variables and data structures that we can use in R. We'll first look into the possibilities that R Studio offers us, and then we'll work with a specific dataset, with the CAG dataset, to basically put into practice all the various things that we learned in this class. Let's start with different data structure that R offers so that we can understand what types of placeholders we have to save data. As I was saying, data structures are basically placeholders, are ways of saving data in R. We can use vectors, factors, lists, data frames, and matrices and arrays. Okay. In this course, we'll mostly be using data frames. Matrices and arrays is something that you need to know, but we will probably not be using very often. Let's start with vectors. So a vector is basically a placeholder that allows us to store a set of values, and each value is called an element. Elements can be of different types, so we can have a vector of integers, a numeric vector, vector of characters, vector of logical values, and then we also have special like null or not available. How do we create vectors in R? So the name on the left hand side is basically the name of the vector. So every time we say name, we're going to be referring to a set of 3 names, which are Anne, Mary, and John. Okay, so we create a vector with a C command, and between parentheses we put all the elements for that vector. Let's go. We're going to be, trying the different commands that we talk about in R. So for example, if we want to create a placeholder, that's basically a vector that holds name, it's C, and between brackets we put all the elements that we want the vector to have. Okay, so we write name. Now, name is a vector that has 3 different values. We can also create another vector that has, for example, temperatures, which in this case are numeric values. And we can also have, for example, another variable, which is Boolean, right? True and true. And basically in this case, what we have is a value that's going to say whether a person and a given temperature has flu or not. Okay, so we have just created 3 different vectors with 3 different types of elements. If you want to access an element of a vector, you just use the name of the vector and between brackets the position. So in this case, temp2, we are accessing the second element for the vector temp. Okay. There's another type of placeholder data structure in R, which are the factors. Factors are a special case of a vector, but basically for nominal variables. Okay, so imagine, for example, that we want to define a variable like gender. I acknowledge that some people do not identify with binary male or female categories, but for this example, I will use only these 2 labels. We could initially create a vector of characters, say, okay, we have a vector named gender, and we're going to define a column, and then for each element, we're going to define the gender that the person has, okay? But in fact, that would occupy a lot of memory, okay? Because basically, fem is 3 characters, male is 4 characters, okay? So we would be occupying a lot of memory. So why not just assign a number instead of a set of letters, okay? And that's where factors come in. Think, for example, that we create gender as a vector, okay? That basically can have only 2 values, female or male. Okay, and that's exactly what the command that you're seeing in this slide means. What this means is that, we are creating a vector named gender that has 3 different values, but actually the values that it can take are only fem and male. Okay, these are the factors that we are allowing. So for example, if we go here, we create a variable named gender, and we create it as a factor. Okay, so it's going to be a column that has values female, female, sorry, and male. So we are creating a vector named gender, okay, but instead of just creating it with the three values, fem for Anne, fem for the second member of the vector, and male for John, for each of the elements that we have in gender, in names, right? So Anne is female, Mary is female, and John is male. Instead of creating that as a column, we create it as a factor. And what this means is that then when we click on gender, gender is a vector that has these three values, fem, fem, and male. But actually, gender can only have two different levels. Okay, levels are the different values that a factor can take. So it's kind of defining a limited set of values that a vector can take. So instead of saying, okay, any value is possible, no, we are only allowing these two different levels, fem and male. Okay. Another example would be, for example, with blood. You can also explore this one. Okay, so we can define blood as a factor too, and basically each of the names that we have here. Let's go again. So Anne, Mary, and John will have different blood levels. Okay, so in this case we could do something like, okay, let's assign them blood to each of them. We create a factor. That column, Anne has value A. Mary has value AB, and John has value 0. Okay. If you check blood, we have two lines. The first line has the values for that vector, and the second line has the levels that blood can take. Okay, so not any value is permitted. We only permit 3 levels. If on the contrary we want to change that, okay, what we can do is actually redefine other types of labels, as you see in the slide. Okay. Another data structure that we have are lists. Lists basically are a special type of vectors that can store different types of values. So unlike vectors where each element is of the same type, a list can have elements of different types. So for example, we've been defining names for Anne, for John, and Mary. We've been defining their temperatures, whether they have flu or not, their gender, and the blood type. Okay, so we can actually create a list for each of the subjects. So for example, for Anne, we can create one list that will have her name, her temperature, whether she has flu or not, her gender, and her blood type. Okay, and in fact, we can even name the variables. So the list will have, in this case, we're saying that we're creating a list that has a variable named name, a variable named temperature, a variable named status, a variable named gender, and a variable named type. Okay, and basically, if we repeat this for all the subjects, then what we'll have is one list per subject. You can try that. And finally, data frames are one of the most important data structures in R, and in fact, we are going to be using it a lot throughout this course, so it's important to understand this. It's very similar to a spreadsheet or a database. Okay, so think of it as a 2D structure with different rows and columns. How do we create a data frame? A data frame is created with the command dataframe, and between parentheses you have to put the names of the variables that we are including in the data frame. Okay? So in this case, for example, we can create a data frame named medical that's going to have, all the different values for all the different individuals that we mentioned before. Okay? So for example, let's go back to our studio. We can create a data frame named medical. Okay, that's going to have name, temperature, flu, gender, and blood. Remember that all these are variables that we have already defined, right? So basically, what we're going to have, and what you're looking at, is the data frame. We have a data frame that has 3 different rows, 1 per element. Each element is an individual, and each individual has a set of values assigned to them. Okay. If you want to access to a specific feature, you can use $sign. So name of the data frame, name of the variable is going to give you all the values for that specific variable. Okay. Similarly, you can have medical blood, and it will give you the blood type with the types of levels that it has. Okay. So A very important thing to mention also is that R automatically converts all character vectors to factors, okay? But this is not always the case. So if you think, for example, about name, name is not a factor, okay? We cannot limit name to a set of potential possible strings, okay? But name has to be completely open so that we can put any type of name. So in order to basically eliminate the fact that name is a factor, what we can do is use a command that R has, which is strings as factors equals false. Okay, so when we create the data frame, we're specifying, look, name is not a string, and I don't want to use it as such. Okay, so when we create this, we can add here strings as factors equals false. Okay. And now the names that we have here will not be factors. Actually, I should have shown it the other way. So let me create again with not strings as factors. Let's create again the data frame. Let's check name. Okay, I should have done this before, sorry. Basically, we create the data frame and we check names. Names are in fact considered a factor. Okay, so the command that I just wrote here is basically to avoid this. So if we say strings should not be factors, then we look again at the content of medical name, and as you can see here, it does not have any labels associated, so it's not a factor anymore. Let's do some exercises with data frames, okay? How can we extract all the names in a data frame, all the names and statuses, a specific value in a specific row, all rows, and so on. So let's look into that. For example, how can we extract all the name? We've already done that, okay? Basically, medical dollar name will give us that column. If we want to extract all names and statuses, okay, you can just say I'm going to start a column that has name and flow. If we want to extract, for example, values in row 2, element 3, it's again brackets. So we use between brackets 2, 3, or for example, if we want to extract values in rows 1 and 2 and columns 3 and 4, we specify that as columns. Okay, so let's try, for example, that one. We write the name of the data frame, and then between brackets, we want to extract rows 1 and 2, columns 3 and 4. Okay, so first thing is rows 1 and 2, and the second thing is columns 3 and 4. As you see, we have here what we wanted to extract. And you can also, in fact, use the names of the columns, right? Remember that the frame has, each column has a name. So you could always say, okay, I don't remember the number of the column, but I know that what I want to extract is the temperature and the gender. Extract temperature and gender, and those are the two columns that we extract. Okay, it's always useful to give names to columns because we don't need to remember numbers. Okay, you can practice, here many other things like extracting a row or rows or columns and so on. You can do it on your own at home and try it at our studio. And then finally, we're going to define the last data structure, which are matrices and arrays. Okay, we're not going to be using them a lot, but you need to know what they are. A matrix is a two-dimensional table. It's very similar to what data frames are, but they are much faster in terms of processing time. So typically when we have complex math processes, we typically use matrices instead of data frames. The way we create matrices is with the matrix command, and between parentheses we specify the elements that we want to put into the matrix, but also the numbers of rows or columns. Okay. For example, the first command, we're just saying I want to create a matrix that has these 4 values, A, B, B, D, in just one row. The second command is going to have the same values in 2 rows. Okay, so basically we are saying not only the values that we want there, but also how we want them distributed. So we are creating a matrix again that's going to have the following values: A, B, let's change it, I'm going to say C and D. Okay, and then once we have that, I'm saying, okay, I want these values to be just in one row. So if you check M, we have just one row with 4 columns. But we could do it differently. We could want the same values but distributed in 2 rows. So this means that you have 2 rows and 2 columns. Okay? And similarly, you can also play around with, for example, number of columns. But this is the way matrices are created. And to access elements in a matrix, again, bracket terminology. First element is the row, second element is the column. As I was saying, whenever we want to do math processing, typically matrices are much faster. So if we have the numbers in a data frame, we'd like to convert it to a matrix, and the command to do that is as.matrix. Okay. And similarly, you can also convert other types of variables into integers or numerics with the same type of conversion function, which is as.integer or as.numeric will make that conversion too. And finally, arrays. An array is a much more complex structure, okay? An array basically is similar to a set of matrices, okay? We're not going to use them, but just so that you get an understanding of what is it that we're talking about. Imagine that we have 3 individuals who are running weekly, okay? They run every day during 4 weeks, and we want to save the running times. Basically, we need to create a data structure that saves for each individual the running times per day for 4 weeks. Okay, so we could see this as basically an array that's going to have 4 by 7 by 3. Okay, meaning that we have 4 weeks. For each week, we're going to have 7 days, and for each weekend day, we're going to have input for all 3 individuals. So we go ahead and create that array. The command to create an array is array. So test array would be the name of the array that we are creating. We use the command array to create that array. The number 1 means that all the elements in that array are going to be equal to 1. And the dim command basically specifies the dimension. So we are creating an array that has a 4 by 7 by 3. Okay. So if now you take a look at what you've created, basically what you will see is that you have 1, 2, and 3 different matrices, right? Or data frames. And basically for each one, you have 4 weeks and 7 days. So first one could be individual 1, individual 2, and individual 3. And for each individual, you have 4 weeks of 7 days each. Okay. You can play around with different data structures, okay? Try to create them, access the values, and make sure that you understand what each data structure does. And next, we're going to look into the CABI set.